This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Modern frontier science operates in an actively adversarial epistemic environment. The assumption of a purely cooperative, truth-seeking academic consensus no longer holds against the sheer volume of generated data and institutional pressure. The primary systemic threat in this environment is a condition we define as epistemic inflation. This network graph illustrates the mechanics of epistemic inflation. It occurs when the mass of symbolic claims, hypotheses, and published papers expands much faster than the volume of actually validated, proven knowledge. Left unchecked, this environment incentivizes prestige laundering. Researchers and institutions begin using high-level branding, narrative force, and complex vocabulary to substitute for the rigorous satisfaction of a mathematical or empirical burden of proof. Traditional peer review relies entirely on human consensus to catch these errors. Under the continuous weight of high-volume, high-velocity publishing, that human consensus degrades. Two specific threat vectors exploit this structural weakness: epistemic distortion, which frames weak claims as verified discoveries, and provenance compromise, which obscures or breaks the evidentiary lineage of a document so its origin cannot be audited. Because human review boards are vulnerable to these vectors, an institution's historical reputation is no longer a sufficient safeguard for governing highly sensitive, dangerous, or dual-use knowledge. The GILC doctrine replaces this entire model. Scientific governance must move away from advisory PDF guidelines and human committees, migrating directly into a deterministic, state-bound digital execution runtime. Without cryptographic enforcement of a claim's truth and trace, high-stakes science ceases to be an asset. It degrades into a critical national security vulnerability. To solve this, the Universal Knowledge Corpus, or UPC, is built as a rigidly layered 3D topology. It is a structured constitutional hierarchy, entirely distinct from a flat, searchable database. The absolute rule governing this topology is the prohibition of upward dependency. Experimental, unverified content placed in the outer layers can never silently dictate or alter the standing law in the deep constitutional kernels. 3 structural spines run vertically through these layers, locking the entire corpus together into a coherent, verifiable fortress. The first spine is DFT, marked in white. It is responsible for maintaining the core fabric logic and enforcing the Institute's baseline governance invariance. The second spine is FQFT, marked in amber. It handles spectral validation and ensures all admitted research adheres to strict entropy constraints. The third is TFR, marked in blue, which governs the secure transport of data and maintains trace coherence across every layer. Individual research objects survive and move inside this architecture by utilizing a metadata envelope known as scroll DNA. Scroll DNA functions as the molecular law of document integrity for the entire institute. It permanently binds a document's identity to its cryptographic trace and locks it to its authorized constitutional layer. Traditional digital files can be duplicated, forged, silently edited, or severed from their proof history. A scroll DNA-bound object immediately flags any material mutation. By combining a strict 3D topology with immutable object binding, the architecture physically prevents unverified claims or tampered documents from ever infiltrating the foundational layers of institutional knowledge. This radar chart maps the CodexStation verification engine. Every research object is assigned a burden vector, a 6-coordinate equation that determines exactly what evidence is required to advance a claim. Status promotion inside GILC is a purely mathematical calculation based on this vector. Human rhetoric and institutional ambition play zero role in the outcome. The first coordinate is the definitional burden, requiring absolute precision in terminology and scope. The second is the formal burden, mapping the exact mathematical or logical obligations the claim must satisfy. The third is the empirical burden, demanding measurable, physical telemetry for any engineering prototype. The remaining coordinates track reproducibility, safety thresholds, and governance compliance. To move a claim from a provisional status to formalized, the vector must hit the precise perimeter defined by the Institute's threshold gates. Reaching the highest status, verified, requires passing the rule of zero-goal proof discipline. The CodexStation explicitly forbids pseudo-formal completion. If a formal proof relies on placeholder tags to skip difficult steps, the system automatically blocks promotion. Attaining verified status also requires the mandatory submission of a cryptographically anchored witness file, the raw mathematical or empirical proof trace that guarantees the claim. If that witness file is ever altered, disconnected, or missing, the system instantly triggers an automated downgrade or total freeze of the research branch. Because human consensus cannot override mathematical proof, the GILC framework entirely eliminates prestige-based promotion from the scientific record. This strict internal verification directly dictates how the institute handles the operational threat of external exploitation and dual-use knowledge. This sorting matrix illustrates the risk classification system used to contain incoming research based on its potential for misuse. R1 identifies content with sensitive but manageable risk, allowing controlled internal release. R2 flags dangerous dual-use capabilities, requiring strictly segmented access and restricted disclosure. R3 designates prohibited open knowledge, research carrying severe destructive potential that cannot be safely released. To safely govern an R3 object, the doctrine enforces a strict separation between establishing scientific validity and providing operational enablement. By extracting the operational procedure data, the recipes and deployment parameters, only the core scientific principle proceeds to the disclosure gate. This process executes the foundational law of minimum sufficient disclosure. This logic gate enforces the constitutional inequality constraint for all public releases. The first half of the equation dictates that a public disclosure can never assert a stronger epistemic status than its internal source object has earned. The second half of the equation ensures the format of the public release cannot be less restrictive than the internal risk classification demands. Operating at the runtime level, this algorithm physically blocks any premature public disclosure driven by internal ambition, media attention, or funding pressures. Within GILC, risk containment always outranks institutional prestige. The institute is designed to govern absolute power without accidentally enabling uncontrolled capability. Applying these rigorous audits to millions of individual objects aggregates into the macro-level capability of the entire institute. The ultimate output of the GILC doctrine is achieving level M6, constitutional capability, where a scientific branch becomes durable institute law. True scientific maturity is not determined by the chronological age of a program, nor by the scale of its ambition. Maturity is strictly defined as the demonstrated stability of truth, trace, and translation under sustained adversarial pressure. A branch only reaches the M6 threshold after a history of repeated independent replication, stable review logs, and the complete absence of constitutional violations. The resulting epistemic infrastructure yields a very specific strategic ROI, an institutional knowledge base completely impervious to narrative inflation, scientific fraud, and unsafe operational leaks. Operating a deterministic architecture is the absolute prerequisite for achieving strategic dominance in modern frontier science. Capital and strategic partnerships are required here, not to fund speculative, chaotic research, but to scale a governed, high-assurance epistemic machine.